My dear students, today's problem is a bit critical from the chapter Indices. It says that if x equal to a by b whole to the power 2ab divided by a square minus b square, then you have to prove that ab by a square plus b square into x to the power a by b plus x to the power b by a equal to a by b whole to the power a square plus b square divided by a square minus b square. So this portion is given, the expression for x is given, and keeping in mind the expression for x what is given, you have to prove this equality. How to do this? Let us start the video. So considering x equal to a by b whole to the power 2ab by a square minus b square, from here see you have x to the power a by b equal to, now if I put x to the power a by b over here, here also I have to put x to the power a by b, means to the power a by b. So the expression for x what you have, that is a by b whole to the power 2ab divided by a square minus b square. Okay, this is power in power. Okay, now you have x to the power a by b, so in this power you have a by b. Okay, the next line what you have, see a by b whole to the power this, again to the power a by b, so you have to multiply this two. Now if you multiply this and this, what you have, a by b whole to the power, see if you multiply this, you have 2, this b on the denominator and over this b will get cancelled out, only 2 a square will remain divided by a square minus b square, which is equal to a by b whole to the power, now see 2a square, you can write 2a square as a square plus b square minus a square, sorry, plus a square minus b square. So instead of 2a square you can write this. Why? Because see, a square plus b square plus a square minus b square, this minus b square and plus b square will get cancelled out, and what will remain? It will remain 2a square only. So 2a square can be written in this form, which is divided by a square minus b square, which is equal to a by b whole to the power. Now see, what is this? You can just break this addition, so it will be a square plus b square divided by a square minus b square plus a square minus b square by a square minus b square. This by this plus this by this, you can break up. Now this is what, a square minus b square by a square minus b square cancelled out, and it will be 1 only. So you can write just 1 in place of this plus 1. Now see, the fun with this is that something, this is something to the power something plus 1. So what does it mean? It means that you can write this one as a by b whole to the power a square plus b square by a square minus b square plus 1 means into a by b whole to the power 1, because we know what, suppose you have k to the power m plus 1, which means what, k to the power m into k to the power 1. K to the power m plus 1 means what, k to the power m into k to the power 1. So a by b whole to the power this plus 1 means a by b whole to the power this into a by b whole to the power 1. Simple law of indices. So x to the power a by b, the value of x to the power a by b, you get this. Now let us find out the expression for x to the power b by a. Now in the same procedure, we shall find out the expression of x to the power b by a. If x is this, then x to the power b by a is equal to this expression whole to the power b by a. So a by b to the power 2ab by a square minus b square whole to the power b by a, which is equal to a by b Now see 2ab divided by a square minus b square whole to the power b by a. A is in the denominator part. If a is in the denominator part, then a and this a will get cancelled out. Only 2b square will remain because these two will get multiplied. This and this will get multiplied. So only 2b square divided by a square minus b square remains, which is equal to a by b whole to the power. Now see 2b square also can be adjusted as a square plus b square minus a square minus b square divided by a square minus b square. See, simple. A square plus b square minus a square minus b square means it will be a square plus b square minus a square plus b square. So a square minus a square and a square will get cancelled out and only 2b square will remain. So 2b square can be written or adjusted in this form. Now let us separate these two. So a by b whole to the power a square plus b square by a square minus b square minus a square minus b square by a square minus b square. A square plus b square by a square minus b square minus a square minus b square by a square minus b square. This. Now see, minus this portion will be 1 because the numerator and denominator will get cancelled out. Same thing on the numerator and denominator part. So if this is 1, or rather to say this is minus 1, so you can write this one equal to a by b whole to the power a square plus b square by a square minus b square into a by b whole to the power minus 1. You can just disintegrate these two. So you can write this. Now a by b whole to the power minus 1 is same as b by a whole to the power 1. You can just reverse these two, the roles of numerator and denominator. A by b whole to the power minus 1 equal to b by a whole to the power 1. Simple law of indices. So what you are getting, x to the power b by a equal to a by b whole to the power a square plus b square by a square minus b square into b by a whole to the power 1. So these are the two expressions of x to the power a by b and x to the power b by a. Now let us use these two obtained expressions on the left hand side of the given or asked equality. See, LHS, what you have? LHS equal to AB by a square plus b square into x to the power a by b plus x to the power b by a. Now what is x to the power a by b? Just put the expressions of x to the power a by b and x to the power b by a over here. So x to the power a by b, you have this, that is a by b whole to the power a square plus b square by a square minus b square into a by b plus x to the power b by a, that is equal to a by b whole to the power a square plus b square by a square minus b square into b by a. So this is what you get if you replace x to the power a by b and x to the power b by a upon with the obtained expressions. Now see, which is equal to ab by a square plus b square, and if you take see, there is a common part in these two portions, that is you can take from this term plus this term, this is common. See, this is common, so you can take out that. So if you take out that, inside what it remains? Inside it remains a by b plus b by a, and if you take out that common, you have A by B whole to the power A square plus B square by A square minus B square, which is again equal to AB by A square plus B square. Now you can do LCM over here into this LCM, it will be AB, and on the numerator part over here, see, if the LCM is AB, you have B over here, so it will be A multiplied, that is A square plus B square. Just do LCM over here and see what it happens. It becomes A square plus B square by AB into A by B to the power A square plus B square by A square minus B square. Now interestingly, what happens now? This gets cancelled, and whatever remains, that is actually the right hand side of what was asked for. So this is equal to now the RHS of the asked equality. So this is the proof or the solution, whatever you might like to call it. This is how you will have to solve these type of problem. My dear students, this is also another part of the series School Mathematics upon the chapter Indices. If you have missed the previous videos, the link will be given in the description box. You can go over there, click the link and see the playlist of this series Indices. If you have liked today's video, do share this video with your friends, like my video, subscribe to my channel, and don't forget to follow my page. Till then, goodbye.